So hi there. So this is our presentation on human-centered intelligent robots. So this is for the compendium for the robotics course. So let me get right to it. So so um, intelligent robots are becoming more and more mainstream in popular media, um, and human-centered intelligent robots have become an important research field that spans across multiple fields in robotics, such as intelligent control and path navigation. We analyze all the contemporary literature in this field and present it in our study for this presentation. We mainly focus on all the subfields that form intelligent robots, and uh, and we present our study uh, in this format. So the first subfield is the field of pattern recognition. So this aspect of intelligence is concerned with recognizing patterns in nature and functioning accordingly. So in all of uh, so in every intelligence test humans take, they're always expected to do some sort of pattern recognition problem. We have come to some sort of agreement that intelligence itself involves some kind of pattern recognition, and we have been trying to make robots recognize patterns that humans are inherently capable of doing, but there are many issues concerned with that notion. But we have seen a lot of development in this subfield in the past decade. So, um, so one huge area is in computer vision. So, computer vision involves using algorithms and optical sensors to simulate something like human visualization and extract the information from real life just using visual information. So first, for us humans, this might seem very trivial, but for computers, we have found that it is very difficult to program. Uh, but in the past decade, we have seen a lot of progress in this field. Ever since AlexNet got their groundbreaking achievement using convolutional neural networks, uh, a lot of more research has been focused on this field, and it has seen a lot of improvements. You can see many mainstream softwares from Google that usually utilize facial recognition. Even your computers that are capable of unlocking your computers by just looking at the faces. Those all come under computer vision. So this has contributed to intelligent robots a lot. The other one is natural language processing. So this field involves everything related to the language, from speech to text to machine translations of text from one language to another. Uh, uh, for us humans, we can naturally learn language and communicate with each other using language. But languages contain a lot of intricacies that we ourselves do not understand completely. That's why we this field for us humans, we can naturally learn language and communicate with each other using language. But languages contain a lot of intricacies that we ourselves do not understand completely. That's why we this field has struggled a lot in the it used to struggle a lot in the 1990s and the 2000s, but in recent years, this area has seen a lot of research interest and a lot of progress as well. You can see tools like Google Translate that are easily capable of translating your text from one language to another. And something like that was not capable 5 or 6 years ago, and you can just do that pretty easily nowadays. So another field that's driving robotics research is the field of computer hardware. So let me state Moore's law, as obviously, because who doesn't talk about Moore's law when talking about computer hardware? So Moore's law states that the number of transistors on a microprocessor chip will double every 2 years or so, which generally means that the chip performance will do so. So this law has holded out for ever since the 1970s up until now, and this is a general rule of thumb, and it's always been true. So the increase in the performance of CPUs has tremendously benefited research in general, and particularly in robotics research, for creating, for facilitating creation of intelligence, and also not only processors, but even GPUs. They have greatly expedited the speed in which machine learning algorithms can run nowadays, and the speed has turned is one of the main keys to why the intelligence robots are becoming are have become so successful in the past decade.
Our next topic is cloud-based computing. So, an introduction to system development of a humanoid robot. As we know, it is very complex to build a humanoid robot. So, due to the development complexity, developers usually desire the best tools and platforms that they can use to build these systems. These tools help improve and develop the algorithms that allows developers to use the codes and functions and also reuse them. Through this, they can decrease the developmental the time and effort they require to make the systems. But even though there are these very good platforms and tools are available out there, they do have limitations on their uses because integration of the tools and these platforms with an already existing system is time consuming and very tedious. And there can also arise a lot of limitations due to incompatibility. So an introduction to cloud robotics, which is the basic area of research of cloud computing in robotic systems. So the cloud robotics was coined by James Kuffner in 2010, and the basic concept behind cloud robotics was instead of having um, all the units required by a robot system to work, such as the processing unit, the power supplies, the computational units. Instead of having them physically present in a robot, the concept was to have the robot wirelessly linked to an external computer and be controlled by it from a remote location. So basically, the idea of having a remote brain for the humanoid robot. So application and development of cloud robotics, its use in the industry. There are definite advantages to the application of cloud robotics and cloud computing in uh, development of humanoid robots is that it reduces the cost for computational power, data storage, and data management by a lot. And it also allows um, the ability of robots to show emergence uh, in that they can be connected to humanoid robots that perform similar tasks and perform a new function derived from their basic tasks. And the application of cloud technologies and cloud robotics has been proposed for various fields, such as mobile autonomous robotic vehicles, an example, Tesla, for surgical robots, for household assistant robots, for humanoid nannies, for robotic nannies, helpers, and for military and rescue robots. Implementation of cloud robotics, cloud computing. An example is Cloud9's Technologies XR1 humanoid robot, which implements a cloud first approach to its machine learning and tasking algorithm. Uh, and it accesses the cloud through a 5G network and is actually the first humanoid robot in the United States to use a cloud based network and 5G connectivity. Another example is the Ericsson simulated space prototypes, where the prototype humanoid robots, again connected to the cloud through a 5G network, demonstrated tasks in a simulated environment where they carried or transferred materials from work cells to a warehouse. Um, the main sensors or the main technologies used for navigation was a laser finder, and webcams were used for pattern recognition of the environment. So there are also limitations to cloud robotics and cloud computing, despite the numerous advantages. There might be latency issues, and it might be a problem in time-sensitive tasks, such as detecting an a failure in an aircraft system or a bomb diffusion, where even seconds matter, and um, failure to connect to a cloud network to just stop the robot from functioning or will make it malfunction. And since it is connected to an external network, it is exposed to security attacks from virtual machines, from brute force attacks, from malwares, and remote machines. Um, since cloud based computing has helped robotics and cloud robotics and humanoid robotics advance uh, in its field of research. Um, the navigation aspect, the navigation process of um, humanoid robots have also advanced. So there are a lot of uh, technologies implemented in a robot to accomplish motion or navigation. So most humanoid robots are designed to work bipedally in different environments, since they are designed to look and work like humans. And these bipedal locomotive systems do have a huge advantage over wheel locomotive systems, in that they are more suitable for navigating complex environments and workplace. Um, so humanoid robots are even designed with special locomotive parts and navigation parts based on the specific task that they do. The major aspects that is required to accomplish a navigation is, of course, the hardware aspects of the robot itself, the hardware parts, and the software um, through which it functions. So the hardware of a robot consists of parts joined through joints, which allows movement in a part or an arm of a robot. And these possible rotations or the possible movement for these joints are called degree of freedom. And since the robots are designed to look similar to humans, they are designed with torso, hips, head, neck, limbs, creating more joints. Um, since with higher number of degree of freedoms, the development process is more complex for navigation, and the hardware parts or aspects that allow navigation are as follows: actuators, processing units, sensors, and power supply. The given charts, they show the different types of hardware material, the different types of actuators, processing unit, sensors, and power supplies used in um, various child-sized and adult-sized robots. As you can see, the common battery used, or the common power supply used in the system, are lithium polymer batteries. The software architecture, the humanoid robot requires software to perform basic functions, to give and receive uh, give and receive signals to perform a task. So, the robot operating system is a collection of software libraries and resources for robot software programming available for developers. And the different aspects of a robot that allow navigation are vision, its locomotion control or walk control, and its behavior control, which is basically pathfinding and motion planning with avoiding obstacles while moving from a point to another point.
So another aspect of intelligent robots in general is human robot interaction. A lot of studies are being done in this field. So in this picture, you see the trend of the studies that have been going on since the 1970s. So in the 1970s, you can see that only three papers were published, but in from 2010 to 2015, you can see that 3,000 papers were published. So you can see an exponential growth in the interest in this field, and that's for good reason as well. This Since like intelligent robots, as I said, are becoming more and more mainstream, it's important to understand interactions between humans and robots in general. And so in this picture, you see the main research areas of aspects of human robots interactions, and yeah, how popular each aspects are. Uh, so, in terms of human robots interactions, there are more mainly four practical areas, application areas. It's the area of uh, mass producing materials and manufacturing materials. It's Another is uh, area of unmanned vehicle control, and you can see that now in like self-driving cars. Another one is the deployment of robots in risky areas that are too risky for humans. Yeah, in that field as well, you need intelligent robots to do perform tasks that a human would be able to do, but like we don't need to put a human in risk. The and the other final applications is human social interactions with robots, making the humans interact with the robots as in social contexts, and making the robots function properly in social contexts. So yeah, that's a big field in for research as well. And so up until now, we've discussed all the current trends and literature for the intelligent robots. So what I'm going to do in this section is talk about the major contemporary challenges that current research is trying to solve. And because if we solve those and gain more and go further in this field, it's going to benefit in the term of the intelligent robots a lot in general. So the first is robot swarms. So yeah, as we have studied earlier, the topic of emergence and making smaller components interact with each other to give a be a common predictable behavior. So we are still trying to study that, and because if we progress in that, that's going to have a lot of benefits to all aspects of robotics. The other interesting one is brain-computer interfaces. So brain-computer interfaces are the direct connections between the human brain and robots. So trying to control a robot without actually using any of your organs, or just only your neural senses, trying to control a robot. So this has a lot of medical applications as well. Let's say if you lose an arm, you can attach a robotic arm, and just using your neural connections control that arm. And the okay, so yeah, this has a lot of potential, but still challenges. There are challenges that researchers are trying to solve. The other is human social interactions. Ourselves do not know all the factors surrounding the social context and cues, and and we are still trying to figure out how a robot can be as the same as humans in these contexts. Another one is creating new materials and designing new fabrication schemes. So this involves so traditional robots just used to use gears and motors for everything, but nowadays we are using synthetic material and even organic tissues in robots. And yeah, this another one is by-inspired robots and by-hybrid robotics. So by-inspired robots are robots that use principles from biology and try to implement those in their functionings. And bi-hybrid robots are the robots that uh, have biological components in them, and like let's say a human lung inside a robot, and just trying to use those components to function properly. And there's been the researchers are currently trying to fix the issues in this field. And the other one is navigation and exploration. We still do not know how to make a robot navigate in an unknown environment, and they're something that humans would be capable of doing, but we still have ways to go, even though we've made a lot of progress in this field. The And AI in general, if AI advances, robotics is gonna advance as well, because the field of robotics and AI are so interconnected. And finally, the, uh, the topic I wanted to mention is the ethics and security. A lot of research have, given how mainstream these kinds of intelligent robots are becoming, uh, a lot of work has been done to make sure that we know how to utilize this technology ethically, and that we do not misuse or any sort of unfortunate events happen.
In conclusion, we can say that with growing interest in research for human centered intelligence and for human centered intelligent robots, the implementation and development with increase in research is rapidly increasing and is almost at a point where a future without humanoid robots is almost unimaginable, and humanoid robots are unavoidable in the future. And even though there have been all these advancements, limitations still apply, and an ideal humanoid system has far from been achieved, even though we may see one from the future. Or, I mean, in the future. Sorry. Thank you so much.